Okay, let's talk about something we all use every single second of the day, but probably don't think about nearly enough. It's the unseen powerhouse that runs our entire world, from the phone in your hand to maybe even the car in your driveway. Yep, we are talking about the battery.
I mean, really think about it for a second. That little slab of metal and chemicals in your phone holds the energy for your calls, your maps, your entire social life. It's it's kind of magical. But how does it actually work? What are the secrets hiding inside? Well, that's what we're going to find out.
You know, our whole modern life is basically built on portable power. We just expect our gadgets to work, right? Anywhere, anytime. That freedom to be untethered is all thanks to one incredible piece of technology.
And that is the lithium-ion battery. It's the true unsung hero of the 21st century. So come on, let's peel back the cover and take a look at the elegant little dance of physics and chemistry that powers pretty much everything you do. So to really get how a battery works, you just need to meet the four main characters in this little drama. Think of it like a play. We've got the anode, the cathode, the electrolyte, and the all-important separator. First up, let's meet the anode. This is the negative side of the battery. Now, when your phone is charged up to 100%, the anode is just jam-packed with lithium ions. It's like a reservoir filled to the brim with water, just waiting to be released. And on the other side of the stage, we have the cathode. This is the positive side. The cathode is basically the finish line. It's where all those lithium ions from the anode really want to go. And that journey, that rush of ions from the anode to the cathode, is exactly what creates the electricity that runs your phone. But wait, how do they actually get from one side to the other? Well, that's where our third player, the electrolyte, comes in. Think of it as a special chemical superhighway that's built only for lithium ions. It lets them zip from the anode to the cathode, no problem. And finally, we have maybe the most important part for safety, the separator. This is a super thin physical wall that keeps the anode and cathode from ever touching each other directly. Because if they touched, you'd get a short circuit, and that is a very, very bad thing. The separator is kind of like the bouncer at a club. It stops any real trouble, but it lets the VIP guests, our ions, pass right on through.
So those are our four players. Now, let's actually see them in action. Every single day, you're putting your battery through its two most important phases, discharging and charging. It's the rhythm of its life.
So when you're using your phone, you're scrolling, you're texting, that's called discharging. The lithium ions are naturally flowing from that full anode over to the empty cathode, and that flow creates the power. Simple. Then, when you plug it into charge, you're just reversing the whole process. The electricity from the wall acts like a giant pump, forcing all those ions to travel back home to the anode, refilling that reservoir so they're ready to go for the next day. It's just a constant back and forth journey.
But, as we all know too well, that journey can't go on forever. Why is it that the brand new phone battery that lasted you all day a year later can barely make it to dinner? No, you're not imagining it. It's just chemistry. Here's the hard truth. Every single time you charge and discharge your battery, every time those ions make that round trip, it causes a tiny, microscopic bit of damage inside. You can think of it like a hiking trail that gets a little more worn down and eroded every single time someone walks on it.
And here's what that wear and tear actually looks like. After about 500 of those charge cycles, a typical battery might only be able to hold about 80% of the juice it could when it was new. That's a permanent loss of 20% of your runtime. And this isn't a defect, it's just a natural part of how these batteries age.
So what's actually happening on that worn-out trail? Well, inside the battery, tiny chemical changes start to happen that can't be reversed. It's kind of like plaque or rust building up. And this gunk literally traps some of the lithium ions. Once an ion is trapped, it can't make the journey anymore. It's retired. And the fewer ions you have making that trip, the less energy your battery can store. Okay, so that all sounds a little bit grim, right? But here's the good news. While you can't stop this aging process entirely, you can absolutely slow it down. A lot. There are some secrets to helping your battery live a much longer, healthier life. See, lithium-ion batteries are a bit like people. They don't like stress, and their biggest stressors are extreme temperatures and extreme states of charge. Constantly charging all the way up to 100% or letting it die completely to 0%, that puts a lot of strain on the battery's internal parts. Same goes for leaving your phone on the dashboard of a hot car. Heat just speeds up all those bad chemical reactions that make the battery get old fast. Even those super fast chargers, as convenient as they are, create more heat and stress. The real sweet spot for a happy battery is keeping it partially charged, somewhere between 20 and 80%, at a nice, comfortable temperature. So here's your simple to-do list. This is your battery's wellness plan. First, treat it like a pet. Don't leave it in a hot car or a freezing one. Second, remember that the 20 to 80% range is its happy place. Third, if you're going to store a device for a few months, leave it with about half a charge. And last, just try to give it a break. Don't push it with heavy-duty gaming while it's plugged in and trying to charge.
You know, the lithium-ion battery has totally revolutionized our world, but this story is far from over. The demand for even better, safer, and more sustainable power is driving some absolutely incredible innovation.
So what's on the horizon? Well, researchers are working on total game changers, like solid-state batteries, which could be way safer and hold way more energy. We're also getting smarter about giving old batteries a second life. A battery from a retired electric car, for example, is still perfect for storing solar power for your house. And finally, we are learning how to close the loop. Advanced recycling is becoming absolutely essential for getting those precious materials, like lithium and cobalt, back so we can build a truly sustainable energy future.
So the next time you pick up your phone, just take a second to remember that incredible invisible dance that's happening inside. From these tiny little gadgets to energy grids that could span entire continents, batteries are absolutely fundamental to our future. So the question is no longer just how they work, but how we're going to innovate and manage this technology for the world we all want to build. Are we ready for what's coming next?